Hi and welcome everyone to lecture 7 of probability and statistics. Today we will learn about probable error in correlation coefficient and Spearman's rank correlation coefficient. Our first term is probable error. This is denoted by P of R, where R is our correlation coefficient. And this equals to 0.6745 times SE of R. And this is standard error in rank correlation coefficient. Our SE of R equals to one minus R square upon root n. Now we have how do we use probable error in correlation coefficient. If first our R less than PE of R, which is probable error in correlation coefficient, then correlation is insignificant. And second, if R greater than 6 times PE of R, then correlation is definitely significant. Our next subtopic is Spearman's rank correlation coefficient. It is calculated when we have n individuals and they are arranged in rank of the two characteristics A and B, and rho, it is denoted by rho, which equals to 1 minus 6 summation di square by n times n square minus 1, where di equals to xi minus yi, where xi and yi are rank of ith individual of A and B characteristics respectively, and summation di equals to summation xi minus yi, and this equals to n times x bar minus y bar, and this equals to 0, because as these are the ranks, so if there are two individuals, they both are from 1 to 10, so their mean is equal, that's why this equals to 0. We will solve some questions on Spearman's rank correlation coefficient. Our question is, we have to calculate Spearman's rank correlation coefficient for data where x have these ranks for 10 individuals and y have these ranks for those 10 individuals. So now our row, which is Spearman's rank correlation coefficient, equals to 1 minus 6 times summation di square by n square minus 1 times n. Now first we have to calculate di. Di is equal to xi minus yi. So this will be minus 5, 0, minus 6, minus 3, 4, 2, minus 1, 5, minus 1, 5, di square. This is 25, 0, 36, 9, 16, 4, 1, 25, 1 and 25. If now we need summation di square, so summation di square will be equal to 5, 6, 11, 11, 9, 20, 20 or 6, 26, 26 and 4, 30, 31, 35, 36 and wait, 5, 5, 6, 11, 11 and 20, 30, 31, 36, 37 and 42. 2, 3, 5, 6, 6 and 4, 10, 10 plus 4, 14. Our summation di square equals to 142. Now we will just put this value in our formula. So this equals to 1 minus 6 times 142 by 10 into 10 square minus 1, because there are 10 individuals. So this will be equal to 1 minus 6 times 142 by 10, 99. So this will be equal to 1 minus 990, and this will be 6, 2 times 12, 6 4 is 24, 5, 2, 6 1 is 6, 852. So this will be equal to 1 minus, if we will calculate this value, this equals to 0.86. So our rank correlation coefficient will be equal to 0.14. Now we will learn about how to calculate Spearman's rank correlation coefficient when we have repeated ranks. So rho equals to, for repeated ranks, 1 minus 6 times summation di square plus correction ratio divided by n times n square minus 1, and this correction ratio equals to summation m times m square minus 1 by 12, where m is number of times a rank is repeated and we summation it every time where m greater than 2. Our question is, we have to calculate rho Spearman's rank correlation coefficient where x and y values are given for 6 individuals. So our n equals to 6. as we know, our row for repeated ranks equals to 1 minus 6 summation bi square plus correction ratio upon n times n square minus 1. We need value of summation di square and correction ratio. We already have value of n. Now we will define ranks to these data. So xi, we can decide the ranks by two methods. We can give first rank to the minimum number, or we can give the first rank to the maximum number. We will do it the way of, we will assign first rank to the minimum number. So first number is 12. Second number is 16. Our third number is 19 and it is repeated 2 times. So we have a problem that if we will give 3 rank to both of them, so our x bar will not be equal to y bar and we have to maintain x bar. And we can also not give the rank 3 to this or 4 to this because they have both the same value. So we will assign them both same values and which will also maintain our summation xi and x bar. So if we have to assign 3 value to 1 and 4 value to second to maintain our mean value, and we have to assign same value to both of them. So we can assign 3.5 to both of them so they can both have the same value and also the same x bar will be maintained throughout the question. So we will give 3.5 to this, 3.5 to this. Now we have assigned 3 and 4th rank. Our next is 23. We will assign 5 to this and 6 to this. Next we have to calculate yi. Our minimum number is 9. We will give 1 to this. Now 14, 2, 18, 3, 24. Now we have 22 repeated 2 times. So we have to give 5 and 6 ranks. So we will give 5.5 to both of them. Now we have to calculate di. 2.5 minus 0.5 minus 3 plus 3. This is minus 2 and minus 1. We have to calculate di square. This will be 2.5 square 6.25 0.25 9 9 4 1. Now summation di square equals to 0.25 0.25 0.5 6 9 15 15 and 9 24 24 and 5 29. Now we have to calculate our correction ratio. Our correction ratio, now we have repeated ranks 1 time here and 1 time here. 3.5 is repeated 2 times. So our correction ratio for 1 times repeated rank equals to m times m square minus 1 by 12. So this will be, m is 2 times because this is repeated 2 times, 2 multiplied by 4 minus 1 by 12 plus, now y in yi 5.5 is repeated 2 times, so we will have 2 into 4 minus 1 times 12. But for this also, so this will be 4 times 4 minus 1 by 12. 3. 4 minus 1 equals to 3. So it will be equal to 1. Now we will put this in row. So 1 minus 6 times 29.5 plus 1 divide by n is 6. 6 into 36 minus 1, 35. 1 minus 6 into 30.5 divide by 6 by 30. You can divide 6 by 6. So this will be equal to this is 35. So row will be equal to 35 minus 30.5 divide by 35. 4.5 divide by 35. If we will just to remove the decimal, 7, 9. So this is 9 by 70 and you can calculate its final value on your own. So this is our question solved. If you will calculate this value equals to 0.129, and we are ending our lecture. We will meet in our next lecture.